I think the recording was kind of stuttering for some reason. So let's see if it's working now. Yeah. Okay. So what else can we do? We can do, let me reduce. You can actually use the arrows to, do another stat GPU and go back to the previous commands. And you can also check if you insist on the virtual shadow map system, insist or need to, sometimes just need to, you do the R shadow, let's see, R shadow virtual max physical pages. Yeah, that one. So that you can limit how many areas of the virtual shadow map you're using. Of course, we're not using virtual shadow maps here, but that's a good command to know about. You can use that to limit the number of pages that would be created from a distance. It usually keeps the quality without any big problems. Okay, so let me stop here and let's get rid of the the profile GPU of stat GPU actually. Stat GPU. Nope, not even that one. It's the detailed stat data and stat units. Okay, so what I'm going to be doing now is just checking the possibility of optimizing draw calls because that's something that's really important in terms of optimization when you're doing multiple actors like we're doing, right? So um, there are a couple ways to do that. Something called ISM or instance static mesh, instance static mesh, which basically batches a number of meshes into a single mesh, which is, really, really performant effective. The limitation is the fact that it needs to use a single material. So it's good for trees, vegetation, things like that, where it's just, you know, a solid shape. So it's a static mesh, and you have a bunch of them. And even better is the hierarchical ISM or HISM, hierarchical ISM. So those techniques, they basically allow you to batch a number of them instantly. They're very good for when you have a bunch of assets existing in your scene. For moving actors like that, I'm not sure it's going to give us a performance boost, but at least I can show you the logic behind that. We just check our time. Yeah, that's 4:25. So let's just speed that up. So let me show you really quick what I mean by that. And the top-down character, whenever I spawn the bullets, after I'm done with all of them, because I just spawned them, and the completed, I would do, well, actually, um, that's not a great approach that I'll be doing here. I just want to show the batching thing. The right thing would be storing that into an array of spawned actors, right? And then you would batch everything in that array. So don't do what I'm doing here. That's just for, for to make it faster, for us to see, not to make it faster in execution. But anyways, I did just get actor at all after actors of class. All actor of class with tag is faster, just so you guys know. So that's something you can do. And usually you don't want to do get all actors of class on on anything but event begin play, right? So get all actors of class BP bullet. And basically you do the for each for all those elements. Then you drag that from the array and for each loop, just connected everything. And I do um, an add instance in the loop body. Add instance. And you have a couple options. Could be add instance or add instance. Well, um, yeah, add instance transform. I think we can use transforms interchange instance. This will do it one by one, or I can just assign entire array. Let's do it one by one. Okay, so that's an instance static mesh component node. So that's what we're creating basically. So let's just promote that to a variable and just assign the element uh, that we're carrying out here as array element, not completed. I just want the element to be, should be cast into an instance. Let's just try casting that to, it is an actor. So let's see what it's expecting to get. Instance mesh component. Yeah, have to assign this into that. So let's promote that to a variable. Yeah, this is the object reference, which takes the, that's too bad that it's an object reference of interchange type. So we'd have to create the structure first. Let's see what we can do. Target, instance transform. Yeah, have to convert that to, or assign that to the instance mesh. I might have got the wrong node because add instance. That's for skin mesh. So let's see. Add instance scene components. Yeah, because there are a couple for instance skin mesh. Yeah, instance static mesh, that one. But still not taking the element, just taking the self. So I won't convert that instantly. So instance transform that I can plug in here. Yeah, it's probably not the best way to batch it like that because the instance wall space, it's not apparently not available. Let's see if I can find it here. Instance set custom hierarchical ISM. Let's try this hierarchical. Um, yeah, that's the IJSM that I mentioned. It's very similar and slightly better, honestly. So let's see if I can add any element to it. Yeah, still not possible. I have to convert that. So yeah, this will require another process that will require creating a container and converting. So that might take a bit more time to do. So yeah, just for reference, just know that you can create that batching. It's not optimized for mobile elements, so that might be why it's refusing to sign it. But batching is cool for static objects, and it's one of the things you guys can check for removing this spike related to the spawning of multiple actors at once. Another thing you can do that it's more straightforward is to not use spawning and destruction. You then would use what we call a polling system or object polling. which is just literally an array of actors. So you could do like, bullet pool, and that would be an array of actors, object reference, and you can make it public. And most importantly, turn that into an array. Okay. So all you would do is you would pre-spawn them instead of, spawning them at once. You would just use the bullet pools which are already here. Obviously, the problem with that is that you have to manage the state, so to know if they're released or not, or make sure that they're released, in a really naive fashion, like um, just release them every time they after a lifetime they're destroyed. Okay, so that's one thing you can do, which, there's some cool videos online on how to do that. It's pretty simple, but takes some time. You need to have this entity here, having something like in use, so you know if it's freed or not, which would be set to, it's a Boolean, set to true or false, depending on the if it's currently been used or been viewed or not. And it'll only use the elements from the bullet pool or whatever pool you want, which are not in use. Okay, so that's another thing you can do. Something else you can do is to basically um, move your code from blueprints into C++. And that's, not specifically easy to do every time, but for, this kind of thing where it's spawning and destroying, because it should be destroying, right? After some time. That's also pretty obvious optimization, like um, where you just take some time and the very own bullet destroy itself after some time. So it just would having bullet the um, set timer or just delay. I think delay is faster, just delay, and it's gonna last for like 2 seconds, and then it destroys itself. Right? So let me just remove those two guys. And you can make that into a variable and call it lifetime. Okay, and make it public. Okay. And then every 2 seconds, those guys will be removed, and that'll prevent them from stacking like crazy. You know, of course, as they're being removed, that's still not optimal, because you're destroying instead of recycling. So recycling those bullets is a pretty smart approach. But yeah, first things first, get rid of the stacking elements. You see how the frame time is now within reach. It's actually 60 frames per second all across, because you're no longer just spawning indefinitely. A minor update. And notice that I also didn't use the tick event. And since I'm not using the tick event, one of the simplest and best really things you can do is to get rid of the tick every frame toggle, because that will take some processing toll even if you're not using the tick event. So of course you can use tick and set your own interval, which would be pretty much the same as, what we did here with set timer by event. But um, this has its own tool, right? Even if you use it, like set it to spawn every 2 seconds, etc., has its own overhead on the system. So always prefer to start with tick enabled equal false and just work with events for communications. Open save. And let's hit play. And yeah, we get a little bit more performance. You see that we're now below 15 frames per second. What else can we do? We're already using timers, managing the projectile. Luther asked about for every bullet from manager class help, so it's just one tick enabled rather than hundreds. The thing is that bullet is using the projectile movement component, which is it's pretty optimized. Like every native component is it's very optimized. So I wouldn't count on that bringing you any specific benefits. And especially because the actual transformation that it's doing is almost nothing. There's no gravity or physics being calculated. You can disable simulation, but I don't remember if that will disable its own movement or not. We can check for that. If simulation is disabled, you don't need to disable speed collision, but we can try that. Let's see. Yeah, it won't move without simulation enabled, so not usable. Um, you can play with the time step if you want, because time step is basically the physics step if you think about unity terms. So yeah, you can play with that to make it less frequent, but that might not result in the most fluid movement. And you can use other strategies like instead of projectile movement, you can use the lerp node. It's a mathematical node between two positions and just calculate the end position, start position, and add a graph to it. That's something else you can do. But honestly, I really doubt you're going to get that much of a boost because, like I said, it's a pretty optimized component in itself, and you're not doing much. What else can we talk about? Yeah, never or that's another tip. That's in terms of coding. And of course, this project is super simple, but try to not do casts, right? Out of pick and play. So, like I was trying here, yeah, spawn the actor. It's already a class, but supposing I need to do a cast, convert from a class type to another. Avoid it. It's much better to use messaging. And I can show you guys a quick example of how that works. I just saved that. And as we're nearing our questions time, let me uh, just close this down, and I will open other projects. It's a game project that we built during our classes, and I'll show you guys that how we dodge ticks to keep performance high. Ticking is usually um, very expensive, so you want to do that, be it in blueprints or C++, try to focus on events and interfaces. Let me show you really quick my projects. GDP um, 13, there's thanks, GDP 12, GDP 13. I think that one it's a good example. Okay, so yeah, here's the game prototype that we're building, just controlling the tank, destroying incoming NPC tanks, and you have to protect the pump jacks, etc. And so the thing is, we use the game mode as a kind of like game manager, And notice that there's no event tick. And as such, you can easily disable tick here because it's all based on events, right? So for instance, Mega Bomb triggered, it's a custom event for when the Mega Bomb button is clicked. And it calls an event dispatcher. An event dispatcher is just like um, a delegate, right? So it basically stores links or references from many NPC tanks. So you have those tanks with the self-destroy or destroy, I can't remember, self-destroy function being stored there. Okay. So they store the reference in that event dispatcher. It's not the event dispatcher that's responsible for that. And since the game mode is a class available to the entire project, it's a great it's a great place for you to do your singleton like manager. Do not abuse singletons, of course, but for really, really high level game rules, it's a good option. So when you call this guy, basically, when you run this, basically it's going to be running indirectly all the methods, the self-destroy methods in every NPC tank in the game. And that's how with a single button, you destroy everything, right? So that's the typical good usage of that. You can also send messages, for instance, the shell here, it it uses the interface. So see, there's an interface for armor, and for when it tries to apply splash damage, it checks for all actors around the projectile hit, the position where it hits, and then, considering valid object types that I assigned, it just loops through them and tries to apply damage. And that's a message. So if I click here and I do apply damage, you see that there are a couple options. It could be the internal one, but it could be the message from BPI Armor. And messages are just amazing because they do not require you to check if the target is valid or not. Notice there's no is valid check here. It just sends the message. If there's a match, if the interface is implemented at the target object, the message will go through. Otherwise, it'll just be ignored. So it's a great way for you to make soft connections between objects dynamically instantiated in the world. So you can notice that if I open API Armor, there's it's got you know very simple functions like try apply damage. It just takes one input, which just the value of the damage. Get health, it's actually a request. It's a message which returns a value. Set max health, it's the same, right? And died, it's just another message that you can send through this interface. So any object like the NPC tank, which implements the interface here in class settings, like BPI Armor, just click Add and find your own interface. It automatically is gonna respond to those messages, and you basically gain automatically all those events here, like try apply damage. So just try apply damage, and you get the event in BPI Armor. Of course, there are many, so that might be a bit confusing. But just if you read what's before it, you see that there's BPI Armor related. That's the one you want, and yeah, of course, it's already assigned here, so it won't do the same. But anyways, you can get those events which work for both the NPC tank and the player tank. So the player tank also takes that. Let me go to the default event graph. It also takes the event died event. It takes the try apply damage event. So you basically generalize all the damage communication, damage armor communication using interface. That's totally decoupled and you get rid of using tick. So if there's something using tick, um, basically it's something that's client based. This is on the client. It's basically to set the rotation of the turret as you move your pointer around. So yeah, that's a really recommended way to do things where you just communicate things and set damage, right? And whatnot by not keeping hard references. Okay. So yeah, that's um that's a wrap for some of the tips. Of course, there's way more to talk about. If I had time, I would convert our script to C++, and just so you guys could measure the difference in execution, even without object pooling, just converting that blueprint into C++ would be a big gain in performance, but we're already below 16 milliseconds, so that was the goal that we wanted to achieve. Okay, so yeah, let's take advantage of our final 30 minutes or so. I will open it up for questions and about the course, about Unreal Engine, about optimization, whatever you guys want to bring.
I got one question, Breno.
Yeah, go for it.
So is this performance workflow pretty much the same if you're building like a cross-platform game and you're, maybe trying to support like older consoles?
Yeah, there's a really good trick that you can use for if you're targeting game consoles. It's to install Unreal Engine 4.27 because 4.27 basically it's the most recent version of Unreal Engine without all the bells and whistles. So you create an empty project from that version and it's stripped out of everything, ray tracing, lumen, Nanite, which we didn't even cover because not enough time. But yeah, basically it's a very stripped down version of end project settings. So you just create a project there and you just migrate it or open it in 5.7 and you can right click in Explorer and say update to Unreal Engine 5.7. Okay, and that's going to give you a really lightweight footprint to start from. But yeah, optimization after that, after it's the project settings are light enough, no abuse of ray tracing, global illumination, etc., which is going to lower your GPU tracing sensibly. The rest is optimization in terms of um, logic and pooling when needed. But yeah, don't do anything before you're sure you need it. Just like I was showing you guys, like, yeah, it seemed like pulling would help, but with around 100 projectiles on screen, we were still getting 60 frames per second. So if your game will be like that, where you have those, multiple projectiles and it's around 100 max, you probably wouldn't benefit much from pooling. So why would you spend time building a solution with pooling before you actually need it? So yeah, premature optimization, that's the source, is the root of all, like some smart programmer once said. But yeah, you'd go through layers. What do I need to optimize? Is that graphics? Okay, I focus on that. Maybe it's the texture size in your target device. Then you reduce texture size. Maybe it's the shadow mapping system. You go for that. So those techniques that I've shown is going to be a good guide. I would start from graphics first, and after that, I would go and check the actual spawning destruction, disable ticks from everything. Just go through every major class in your project. Make sure you're using as much event-based communication, interface-based communication as you can. Get rid of, start with tick enabled on every actor that you can. Just deleting the event tick node does not help. Just that's an important thing to know. And I wouldn't go, when you get to the bottleneck of logic, I wouldn't go straight to C++, I would check on which blueprints are using math first and foremost. So this one actually was a good candidate because it was loop iterating and doing some computations like rotation, getting active rotation whenever I spawn things. So that's a very good candidate to be ported to C++. I think we actually should do that in our course. It's a good candidate, like I said. But do not waste time like trying to convert animation blueprints and things which are already super optimized in a real engine. Doesn't make sense. Like if you're using EQS to check for AI events, you can get some performance boost um, from AI doing that in code, but mostly the nodes on the behavior trees or state trees, but not the actual structure. The actual structure is where the editor exceeds. And at the end of the day, it's like if you're using Unreal Engine, you want to use its graphical functions, you want to use its environment to create your game. You don't want to do everything, from scratch on code. If you want to do everything from scratch on code, that's fine. Just, start doing things in SDL or Raylib or any other C++ library. You're going to get super amazing performance. And it's going to take years of your life, even with AI assistance, but that's up to you. But anyways, just as a general rule of thumb, start from graphics, optimize it as much as you can, like it did. Once you're satisfied with that, move to code and do this first pass about ticking. And well, if you know about blueprints and event dispatchers, make sure to use them to your benefit. And interfaces are just amazing. Just abuse them as much as you can. Okay,
Breno,
Cool.
Breno,
Thanks.
if I may, because I was
go on.
surprised on your screen, I saw Quark, Quake Army Knife. Um,
That's for my daughter. So
oh, I see. Because I've actually, long history. I used to work on those engines. So I was surprised because if you can see the screen behind me, this is
oh
actually, yeah, well, I use Unreal 5.7. I use bake lighting. I actually
oh
turned
cool.
off. So I'm actually, and so that did give me performance.
Yeah.
And so my bottlenecks are actually on the CPU. When they're without AI running around, I'm over 100 frames a second, with this type of background.
Uh-huh.
So my issues are more inherent to and skeletal meshes, too complex. I found one time where I turned on overlap on the skeletal meshes. That's a big no-no.
Uh-huh.
That's a big performance hit. So anyway, I just want to let you know that you could investigate also baked lighting versus not.
Yeah.
It's not going to double your frame rate, but you
Mhm.
can see a 20 or 30% gain with side effects. So like all the skeletal meshes that run around, they have to use regular shadowing.
True.
Yeah, and there's a whole slew of things that go wrong. But anyway, throw that out there. I'm going to stop.
Yeah, yeah. I didn't mention about baked lightings. That's a separate workflow, but you're super right. There are many situations where, baking lights and mixing them with some other shadow strategies. There are many. You can use blob shadows. You can use your own. There's even a trick with adding a plane or a circle mesh below the characters, and then you project, you calculate it kind of like an ambient occlusion from a camera at the top, and you use a shader to project that onto the shape. And the cool part is that you can set your own frame rate for the shadow updating. So if you're, really in a pinch and you want to optimize that to max, you can even do things like for NPCs which are far away from the camera, you lower the update rate of that texture. You make that like 5 frames per second. And as the NPC gets closer to your character, you bump it up to 30 frames per second or not. There are so many strategies that you can use, but you're so right. Yeah. Especially for the tail environments and lots of static elements, the baked lighting makes lots of sense. For our example today, it didn't make sense because too many things moving, not enough static things. But Yeah, you're right. For very complex scenarios, go for baked lighting first and foremost. Thank you for the heads up. Okay, any more questions about the course? Maybe if you guys are interested, make sure to reach out to our staff. Only in the game dev group would I be listening to a talking dragon with glasses. I think it's amazing. Not sure if it's glasses, but I see headphones, right? So yeah, it is a game dev group for sure. All right, make sure to reach out to our team, to our staff, Vertex, to check on our special conditions, especially for you guys who hopped around if you want to learn a little bit more. And yeah, it would be a pleasure to be studying with some of you guys, just like I am with Cole right now with our GDP 13 cohort. Thank you very
Yeah.
much, guys, for you sticking up to all those 2 hours. I hope it was useful and hope to see you soon.
Thanks,
Cheers.
Breno.
Thank you very much. Bye bye.